So hello everyone. We will solve this today's LeetCode problem. This is LeetCode medium. Let's see what is this. So this is remove k digits. So we have given a string nums representing a non-negative integer and an integer k. We need to return the smallest possible integer after removing k digits from num. So this is given that this is nums and string and this is k is equals to 3. We need to remove and k digits from this num such that it becomes the smallest possible integer value, right? So let's see if this is the first example. This is 1432219 and we need to remove 3 digits from this so that it becomes the lowest smallest possible integer value. So let's see what we can delete from this. So we will get, suppose we delete 439, so we delete 439, so we will get 12219 1221, sorry, 1221. If we delete 429, so 1221, and let's see if we can build less than this element. So if we delete 1 421, something like this, what we will get? We will get 1328. We will get 1329. So this is bigger than this. We will not take this. Right now what we can remove is 4 3 and 2. Then what will be the answer? 1 2 1 9, right? So this is the minimum, so we will remove this. But how we will think like this, that uh, what will we remove and get this? So one of the approach is brute force here, that we will remove every elements and till k we will remove every k elements from this one by one and see that which element is will formed after removing this k, and we will get this that integer and that string, the minimum possible integer and a string. But that if you see that will take, for removing for every element and for checking that whether this is equals to this or not, that will an exponential, right? So we will have two options here, that we will remove this and we will not remove this till k is not equals to 3. So that will be the o to the power o to the power n, right? So 2 to the power n, sorry. So that will not be a good approach. So what we can do is, so let's think like this. We if we see this example and we see that we need to make this as smallest as possible. So for that we need to see, we need to take a smallest element from 0 to 9 at every step, right? Suppose here in this we remove 432, right? So is there any element less than this 432? Let's see. First we will take 1. Now I will take 4. So if this, and we will check that whether this 1 is less than greater than equals to 4 or not. So it is less than 4, so we can take this one, right? So we will take this 4 also. Now if we try to take this 3, if we try to take this 3, then this 3, so we will check that whether we have already taken the greater number than this. So yeah, we have taken this 4 which is greater than 3. So we will remove this 4 because we have already left k which is equals to 3. Now we have removed, now 3 becomes what? 2, right? Now 3 becomes 2. So and we will again check for this one, that whether 3 is less than this one, but it is not, so we will take this both answer. Now again we will check for 2, this 2 is less than this 3, so we will remove this 3 again because we have already left k. Now this is 1, this 3 is already removed. 1 is less than 2, we will not do nothing. Again we will check again 2, so this is not less than, this is equals to. So what do you think? We should take this or not? So it totally depends on the elements left. Do you have elements left or not? So we have left elements, so we will remove this simply, because we need to maintain a smallest, so we will remove this. Now I have not any elements, I will include all the elements, so this will be the my smallest possible value. So this is something like the same uh, the stack problem, right? So what I am doing, that I will inserting elements if my top element of that stack is greater than the current element, and moving till I am not getting any less than elements, and I have left this k value, right? But here you need to check one thing, that what if there is 0, right? What if there is 0 between them? So if you see, if I remove this 1 only, then it becomes 200, right? Because this 0 value is not considered in my integer, so we need to check for that also. So when you check for that, let's see what we can do. Suppose here 1 is given is 10200 or 300, and k is equals to 2 is given, right? So first 1 is given, right? So 1 is what? 1 is deleted, right? 1 is deleted, right? And we will not solve this again. So in this case, if I take 1002300, so what we will check? I will insert 1, then I will move to 0. So this 1 is greater than this 0, I will remove this 1 and decrease this 1 as 0, right? But for this 0, I will check this 0 is again the same element. So the previous what we are doing, that we were doing that if the same elements are there, we also remove this k. But if you see, for this 0, if I remove this 0, then it will only decrease my number of chances, which is k, but don't affect anything on this number, right? So we will not change this. If there is same elements, we will not delete that, right? So if you see here, for this double 2, if you don't change this, and if you don't delete this after getting again equals elements, and if you get 1, this we can already always can remove the next and the previous greater than element, and the answer will be always same, right? So if the number of elements are same, we will not remove this. So we will insert this 0. Now we will come to 2, and this 0 is less than 2, so we will keep it, and this again 3, so this 3 is greater than this 2, we will keep it. Now again this 0 comes, this 0 is less than this 3, so we have already k left, we will remove this, and we will simply remove this also, and now I will insert all the elements. So this will be the answer, but the integer answer return will be 200. So here this will be the approach. So what I am doing, I am inserting elements in my stack. If I am getting any element, any number, any digit, right, greater than my top digit of the stack, then I will, and also one thing, and I have, and k is greater than 0, then I will remove the top value, right? And at last what I will do, I need to check that whether in this stack this 0 0 is left or not. So we need to check the first non-digit number, non-zero number, and after that I will include all the digits in my answer, right? In my answer, and return this. So this will be the approach here. So what will be the time complexity? The time complexity will be O of still n for inserting all the elements in stack, and O of n for iterating all. So that will overall time complexity will be O of n, and the space complexity will be, in worst case, O of n, right? If there is already increasing elements 1 2 3 4 5 6 and like this, and then we will simply check. Also I need to also check after this that I need to also check that suppose this is 4. I need to also check that whether k is, so what will the condition if there is 1 2 3 4 5 6 elements, right? So this is increasing order, so we will not get any greater than number. So if k is already left, k suppose is k is equals to 4, and there is already left this numbers are already in stack, in my stack, and k is also left, then I need to pop the number of k elements present left in this stack. So whether k is left, then I will remove the kth top elements from stack, because we need to remove, right? Anyhow we need to remove the k digits, right? So we will remove all this, right? So space will be also of n, because I am taking an extra due to an extra stack, right? So let's see how we will do this. This is number of size. Let's take a stack. What will we take, indices or characters? Let's take a character, right? At last we need to return character, so I am taking character. So n plus plus. So I will push all the elements in my stack, but before I will check whether this stack is not empty, and st.top value is, if it is greater than the current element, I will pop it up, and also I will decrease, and also I need to maintain a condition that k should be greater than 0, right? If this is correct, then I will push all the elements in num side, and at last I will check whether this k greater than 0 and my stack is not empty, then I will pop this, and at last what I do, I will make an answer, and I will iterate again in this. If this is not an empty, I will insert all in my answer. st.top st.pop, right? So it will store, in reverse order. Suppose we have left with suppose this is 1432 and 1219 is left in the stack. So first 9 will come here, then 1, then 2, then 1. So we need to reverse it, 9121, right? So what will I do? I will need to reverse this. This will be answer dot begin to answer dot end, and then I will need to also check that whether till the first index, till which index the first number is 0 or not. So if answer is equals to 0, then I need to continue this, then this will break, and this is equals to 1, and answer D is equals to I. So this will be the answer, and I will return this answer 0. Answer dot sub str, this I and so let's run this. Okay, yeah, if my answer is empty, if my answer is empty, I need to return here you can see that if my answer is empty, we return 0 because there are no elements, so we return to 0. And what is this? This is so okay, just let's run this. So yeah, so what we have done, that we have stored an stack, then we will check that whether this the top element of the stack is greater than this current element. If it is greater than the current element, we will pop it out, and also need to check that whether this we have the chance left or not. This k is a chance, so we will remove it, and after iterating in all the direction, we need all the string, we also check that whether this k is already left or not, and we have characters in my stack or not. If that is left, then we need to remove till k is not equal to k is equals to 0, because we at least need to remove this k digits. And after that, I will insert all the characters in my stack from a stack to answer, and we will reverse it because it will be opposite in direction. And now I will check first non-zero number. Why? Because 00200 is same as 200, right? So we need to return this 200, not this, right? So we need to check the first non-zero number, and now I will return this answer, and if answer is empty, then we will return 0 simply. So yeah, so let's submit it. This is one. This is 10. This is 1 given. I think we have passed the cases, right? This is 10. So we have 1, so we have inserted this 1 here. Now this empty is not a string, and k is 0 left already, and st.top is greater than num size. We will pop this out and return this, and now I'm inserting this 0 inside it. Now this k is 0, so we will not iterate in this. Answer will have we have 0, and okay, this should not be n, this should be answer dot size. This will be answer dot size. Okay, and this, if it is not equals to 0, but it is 0, so we will iterate again, and this insert will be okay, this will be so what we can do is we don't take the 0, we will take as an answer. if I do like this, if I take this as n, and if this is n, if I take this as an answer of size, what will be the answer now? So this answer, let's see what this answer is coming, right? And it is 0, right? So this answer I is still 0, so we will not break this, and this answer should be here. Okay, so what we can also do is we will check that whether this answer is empty or not, and we will also okay, we will also check this, that whether this and is equals to -1. So we will it means that all the answer have only 0 element. Now we will return this 0. I think that should also work. Let's run. Sorry, this should be or. Either answer is empty or either index is equals to -1. Let's submit it. I think now it will be fine. Yeah, we have passed the cases. The problem was that if the index, if all the answer have only zeros, then indices will not be changed. So if it is, then we will return 0, otherwise we will not change anything, right? So yeah, thank you.